11.8. So this is the last thing we're doing in this chapter. Radical equations. I really would have liked to have added this to the test, that we just took and everything. But I think y'all had enough on your plate already. So, but it's not difficult. It really isn't. Okay, radical equations. You're basically doing like intruder alert type thing. Isolate the variable. But it involves radicals. And there's a special way to handle radicals in this situation. The first step, and you all need to write this down, isolate the radical on one side of the equation. Basically, what you're doing is isolating the variable. You're going to isolate the radical on one side of the equation. Basically, isolating the variable. And I'm going to put that in quotes. Isolating the variable. You better be taking notes. Step 2. Square both sides of the equation. To get rid of radical. So step 1 is you're isolating the radical as if you're isolating the variable. Okay, that's the first step. You want the radical all by itself on one side of the equal sign. Then we want to get rid of the radical sign. Okay, to get rid of the radical sign, we square both sides. Example. Oh, this is kind of dumb, but these are dumb examples. Like, if I want to get rid of that radical sign, I would square it, because that would give you the square root of 9, which is what, Franz? Thank you. Are you writing this down? So you see, we got rid of the radical sign by squaring it and taking it out of, the radical. I did. You don't like it? Is that bothering you? Oh my gosh. Okay, I will do my best to get a black pen from here on out. Okay, I'm going to give you another example. I've been using this like all week, and you're just now complaining. I guess so. Okay, so if I want to get rid of this radical, I'm going to square it. What would I get, Morgan? What would the answer be?
25x2, like under a radical sign.
25 plus x squared, right?
Yeah.
What's the square root of those?
5 plus x.
So, you notice something. That's right. The answer is the same as a radicand. The answer is the same as a radicand.
Couldn't you just,
skip this step?
Yeah.
Absolutely. That's why I'm showing it to you.
Okay.
Because it'd be the same as if I did this. Oh, I don't like that radical sign, so I'm going to square it. That would actually give you the square root of 196, and the square root of 196 is in fact 14. So I can skip this step right here if I just know that I got to square both. Well, I'm going to show you both sides. And if you square this, it gives you the radicand. Valera, do you understand that?
Yes.
Are you sure? Okay. Yes. If you want to permanently sit by Morgan, you can. Go sit over there.
Do we have to wear masks? Is that a question?
Just don't breathe on each other right now. If you
Okay.
are uncomfortable, put it on, please. Especially right now. Right?
Yeah.
So you may want to. Step 3 is to solve, and then you can check it, but really just solve. Okay, hurry up, because I got important stuff. This is important right here. Make sure you write this down. A radical can't equal a negative. Now, we've talked about this. It was even on the test. If it has an, was it on the test?
No.
I know 7th grade did this. For example, you cannot have x minus 3, a radical by itself, equal a negative. The radical has to be by itself and then on the other side is a negative. That is a big no-no. That would be a no solution. So after you write this down, sit back and think about what I'm saying here. A radical by itself on one side of the equal sign and a negative number on the other side. Big ol' no.
Why?
Because that's the rule, Morgan.
It's weird because like.
If we start to solve it, you'll see why. Square both sides, you'll see. My lips are chapped. I don't like that. Look, as soon as I said that, Ariel's like checking out her lips, and Morgan's checking her lips. Yes, chap.
What if you had a cube?
A radical can't equal a negative.
It's like any radical.
Yes, it says a radical. It didn't say some radicals. It says a radical can't equal a negative.
So, but A is like similar.
A radical can't
Like
equal
all radicals.
all radicals. Okay, y'all ready for some examples?
Yes.
All right, first one. Let's solve for x. I have the square root of 2x plus 5 all under the radical sign. And be careful, some of you with your handwriting, not calling anyone out, but chap, you're one of them. But y'all need to be careful with your handwriting because if you accidentally put not cover a number with the radical sign, then you can it'll make a difference in your answer. Or if 5 is not supposed to be under the radical sign and you accidentally extend that line over too far, that's going to mess you up and give you a wrong answer. So there's a difference between this and this. See what I'm saying? So that you got to be really, really careful because you'd solve these in 2 different ways. Okay, so the square root of 2x plus 5 equals 8. Okay, so step 1, we're going to isolate radical. You're all writing this down. In other words, you're going to make sure radical is on one side. Isolate the radical. You're going to make sure the radical is on one side, all by itself. I should say that. All by itself. So, once you have this written down, is the radical all by itself on this side of the equal sign?
Yeah.
Yes, it is. There's no other number. I see this one right here I did as an example. There's that 5 there. Oh, dear. Hold on. I saw the look through the window. I love her. Okay. So, anyway, if your problem looked like this one right here, the radical would not be by itself because you have that 5 there. Okay? And we're going to have to get rid of the 5. But in this case, the radical is all by itself. So step 1 is complete. So then step 2 says to square both sides. So I'm going to do that. I'm going to rewrite my problem here. Franz, are you writing? And I'm going to square both sides. Because what are we trying to do? We're trying to get rid of what? The radical sign. We're trying to get rid of it. Okay, so based on the examples that we did on the other page, Valeria, what would this end up looking like? What would be the end result? Plus 5. All we're doing is removing the square root. Because remember over here, look. We squared. We got the square root of 9. Perfect square is 3. So we're right back to where we began. The answer is the radicand. See this one right here? If we square it, look at the answer. We're back with the radicand. So then in this case, the square root of 2x plus 5 squared is just 2x plus 5. What is the square root of 8? Not the square root. What is 8 squared? Very good, 64. Okay, now we're back in the old days, last year, of intruder alert. So Ariel, what do I move first? You are correct. And how do I move it? Absolutely. See, we've been doing so many other things that we're back to basics on this. So I have 2x equals what? 59. Now, Sophia, what do I do? Excellent. And in this case, I'm just going to leave it as an improper fraction. You can go ahead and make it in a decimal if you want, mixed number, I don't care. At this point, oh, and step 3, I forgot to say, you got to solve. That's an appropriate answer for this. Make sure you do put it, lowest terms, but in this case, it is. So you can turn it into a decimal if you want, mixed number if you want, or if you're lazy, you just leave it like that. And I'm okay with that. Any questions? Yes.
What if there's a radical on both sides?
What if there's a radical on both sides? Well, we would probably move it as a whole. Like do intruder alert. Yeah. No, like from itself. Oh, yeah. I don't think you're going to have anything like that. Let's see.
It says isolate radical, make sure radical is on
You know
one
what?
side.
You're in, oh, look at 20. Oh, but 20, okay. Oh, look at 20 in your book. I like that. Yeah, Ms. Rogers. Okay, so look at it. Let's look at examples.
I was curious.
No. That's a good question. I like how when you try to stump me. Okay, and it's not hard to do. Okay, if you look at number 20, we're not going to do number 20, but if you look at number 20, it goes along with what I was assuming would happen, and New even said, but it has to have the same Radicand. And if you notice, number 20 has the same Radicand.
And if the radical was alone on one side, and we just do intruder and then.
Yeah. That's a good question. Do y'all see what we're talking about? Are you sure?
I can do it too, man.
You know what? We will do that as an example. Okay, so let's start though with examples. Does everyone have their book open to page 472? Is there another one? No.
33.
What? All the way over there?
Yes.
Oh.
That's too hard.
Oh, that sounds like a good one for y'all.
I do point that out.
Majority of them do not have it on both sides. So I don't mind working out number 20. I don't mind. Okay. So let's start with number 1 and we'll move up to that. Let's start small. So number 1, solve and check your solution. Well, we're just going to solve. So we have square root of x equals 4. Okay, let's see. Valeria, how do I solve for x? Square what? Both sides. That's a 2. Okay, so Valeria, what would I get here? And she's correct. Now, if you want to check yourself, if x equals 16, then you're just going to replace this x in the original problem. Square root of 16 equals 4. Well, what's the square root of 16?
4.
Oh, look, 4 equals 4. That checks. So that's how you would check your work, right?
If you do subtraction or addition problem in the radical, you add them or subtract them first, right?
Yep. Okay, good question. So Chap was saying if we had a bunch of stuff going on in here, kind of like this, then you would replace your x there, do all the work, and then take it out of the radical. And
What do you mean replace your x?
if x equals this, and we want to check to make sure we did it right. Yes, I'm sorry. I wasn't clear. Or I wasn't, she wasn't listening. Okay, so we'll replace that x, multiply it by 2, add 5, and then find the radical. And it would be 8.
Oh, but 33, like you said, it has
Can we just start with 1 and then I want to do number 3?
both.
Okay? I didn't work out 33 yet. I'm going to have to work that out. And see that now,
How do
you know, I'm going to have to work this out now.
Yeah.
Because you've done this. Like, I'm going to assign the work, and I'm going to probably sit over here and work it. It's going to make me crazy. I can't let it go. It's probably need therapy. I don't know. You should have seen me in college doing all my math classes. Oh, my word. I would spend hours on one math problem. Couldn't sleep. I would not be able to sleep until I solved it. You understand? You do that? Oh, she's sitting there. Don't tell me. I want to solve it. I will not be able to let it go. Okay. You solve it, and then I'll solve it, and we'll see. I have the answer, but I won't look at it. All right. So no, because that's like cheating to me, and I will not be fulfilled until I solve it by myself.
Okay.
Okay. So isn't it going to be sad when they take away 7th and 8th grade and tell me I have to teach like 3rd grade or something?
Yeah.
I don't know what I'm going to do not being able to teach algebra.
Didn't you use
It is, yeah, but it wasn't good. That's why they moved me up to 5th grade after 1 year of 3rd. I told y'all that. I taught preschool for 1 year. Oh no. So they moved me up to 3rd grade. Oh, no. and then they moved me up to fifth grade,
You don't
and then they
seem
kept.
like a younger
No,
teachers.
I love little
grade
kids.
teacher.
I just like to look at them and
Yeah.
play with them, maybe hold them a little while, and then
Nothing better.
yes, I'll probably be a better grandmother than I was a preschool teacher. But okay, let's get back to this. I can tell Miranda and Keith are very annoyed by now. Okay,
No, they're probably laughing.
now they're probably fast forwarding. Okay, so here we go. So Sophia, how do I solve this? Oh, you're so smart.
In reality, you haven't posted a video yet, so
I know. They will be. Okay. Sophia, what is this? Equals. Very good. Now what do I do, Sophia? And what do I get? You're right. And as Chap said, we're not going to check all of them for the sake of time. But if you wanted to check it, you would replace that x with the 62. You would solve this first. So 62 plus 2 is 64 equals 8. The square root of 64 is 8. And they check. All right. Make sure y'all write that down. If you have any questions, let me know. If you're writing, I'm assuming that you're still writing notes, so I will not continue till all pens and pencils are done. Okay. We're going to bump up to 11. I want y'all to watch this one. It's interesting. It's 2 minus square root of x equals negative 8. What's interesting about this one is this right here. That you gotta, it's kind of like with parentheses. You gotta kind of watch it. But let me just, oh wait, hold on. I said it's kind of, no, wrong choice of words. It's not like parentheses. I misspoke. It's going to be like if you have a negative variable. And I'll show you what I mean in just a second. So, let's see. Franz, what is the first thing I need to do? And then I'll answer your question.
Isolate the variable.
And how do I do that?
By moving the 2 to the other side.
And how do I move the 2?
Subtract 2 on both sides.
Do you know how many times people want to add 2 on both sides because there's no sign here? Just assume. But if there's no sign here, we assume it's positive. So he's correct. So I get a negative square root of x equals what, dear?
Negative 10.
Negative 10. Okay. Now, if you remember in the past, can I have a negative any variable equaling something? No. So the same rules apply here. Okay. So if you recall what we do, we get rid of it here and we apply it to this one, right? So then we're going to take this negative and we're going to apply it to there. So then I'm left with the square root of x equals what?
Positive 10.
Positive 10. So it's just like we did in the past. Can't have that negative x. We can't have a negative radical like this either. Okay, so Franz, we're still not done yet. So what do I do here?
You have to square it.
Square both sides.
And then it'll be x, and then equals 100.
You are correct. Any questions? Yes.
So you know how if you have a radical equaling a negative number, it doesn't have that, so that wouldn't count.
Correct.
You can change it.
If you change it, what do you mean?
Because you can change it, like there's a negative there. Like it wouldn't be no solution because you can change it with that negative.
If that's right. Okay, so I think I know what you're saying. So let's pretend this negative wasn't there. Is that what you're saying?
Right.
If it was this, boys and girls, y'all see that? If that negative there went on the outside and this is what we had, Valeria, you looking? This is a no solution. This would be a no solution because you can't have the radical on one side and a negative on the other. Yes. No, it would be no solution because first you isolate the radical, move the 2 over, and let's pretend this was plus. If we move the 2 over and this is what we were left with, then that tells us it's a no solution. Okay? But like, for example, let's say this was 2 plus the square root of x equals -8. Okay? If that's what it is, then you have to work it out to then find out if it's a no solution.
But why would it be no solution? Because you can still solve it. Like, if it would just be the same as it was positive, because you square them both and then get 64 and x, so x equals 64. So why would that be no solution?
This would be, if we square them both, this would be x equals 100, right?
Exactly.
Okay, so
So it'd be the same thing.
should we try it? You want to try it?
Okay.
Okay, so let's go with this one. Let's pretend this was our problem, okay? We're going to pretend, boys and girls at home, this is our problem. This is what we got. So we're going to go ahead and we forgot that we have to do no solution. So we're going to square, I'm going to use blue this time, both sides. Let's see. I can't remember if I've ever checked this. I'm sure it's going to work. Equals 100, right?
Mm-hmm.
So then don't do that. Okay, so then let's go back and check. Let's put 100 here. So that'd be 2 plus square root of 100 equals -8. Square root of 100 is 10. Does that work? So instead of doing all that, because most of y'all won't check it anyway, they give you the rule that if it's a radical equaling a negative, it's no solution.
Thank you for showing me that.
You're welcome.
Yeah.
Mm-hmm.
Now it's not just a rule.
Do we?
It's
Oh,
like,
I
it
showed you
makes
the rule.
sense.
You like
Exactly.
challenging me. Chap, are you okay to move on?
Oh, yeah.
Okay, good. Valeria, you writing this down? Okay. You understand this mess, Valeria? What we did was we recreated our problem so that we got a negative, a radical equaling a negative, and then we went out to try to check it to see why it's no solution.
Yeah, that's why I put it in my it's.
Okay. Oh, I like that. All right, let's go to number 13. Oh, this is a good one. We have 7 plus 3 times square root of x minus 3 equals -14. New, you want to do this one? All right, go ahead. Talk me through it. -7 on both sides, because we definitely want to do this first. Always get rid of that one first. So I'm left with 3 times square root of x minus 3 equals what? Very good. Are y'all with me so far?
Mm-hmm.
Okay, now I want y'all to pay attention. I had 3 times this whole thing. We're going to pretend like this is a variable. How do I get rid of the 3, New? That's right, guys, Valeria, everyone, y'all looking, Sophia in the back. 3 is being multiplied with this. The whole idea is to isolate this and have it by itself. So we're going to divide by 3. And I'm left with the square root of x minus 3 equals what? All right, now what? Are you sure?
No solution.
It's a no solution. Tricky, tricky, tricky. If you were to continue squaring both sides, you'd probably get an answer. If you choose not to check your answer, you might miss that. It is a no solution because we have a radical here equaling a negative. It's a no, no. Exactly. I mean, I would suggest you check yourself because someone's going to get real mad. I'm going to go around, I'm going to circle, and you're going to rework it and rework it and rework it and get mad. Why am I getting this wrong? Well, because there's no solution. All right. Any questions? Larry, do you have this? Val?
Yes.
You got it? You sure?
Yes.
Okay. 15. 5 plus 2 times square root of y minus 3 equals 27. Chat, you want to do this one?
So you subtract 5 on both sides.
Good, because we do that first.
And you get 2 times the square root of y minus 3 equals 22. And then you divide both sides by 2 to get rid of the 2 on the outside. Then you get square root of y minus 3 equals 11. And then you square both sides. And then you get y minus 3 equals 121. And then you add 3 to both sides. You get y equals 124.
Why wouldn't we add 5 and 2?
Because remember in a Truder alert, let's pretend like this. Wait, this is your answer. Remember in a Truder alert, let's pretend that's a variable. We would move 5, and then we would do this, right? We wouldn't add 5 and 2. So write this down, sit back, look at it, make sure you understand what we did here. Any questions? I'm going to do 20. 5 times the square root of x minus 13 equals 2 times square root of x. Franz, write this down. Plus 26. Okay. I'm going to keep Franz awake. You solve this. No? Ariel, you want to try? All right.
No.
Well, you gave me the look like you're scared. So go ahead and write it down.
Okay, so first you're gonna add 13, right?
Yeah, let's do that. I'm sorry, I got a little excited. Add 13 on both sides. Good, because she's putting the regular numbers on one side, and then she's going to get the radical on the other side. Good job.
So it'd be 5 times x, or square root of x plus.
No, equals.
So equals, sorry.
Uh-huh.
Equals the square root, or 2 times the square root of x plus 39.
Good job. Hey, we're not there yet. What are you talking about?
I don't know what she's talking about.
Okay, go ahead, Ariel.
And then you're gonna subtract 2 times the square root of x.
That's right. Now, Ariel, why can we subtract these two together?
It's usually the same square root.
Right, I can.
Oh, radicand.
That's right. So New had mentioned that previously, that you can only do this, and y'all need to listen. You can only do this if you have the same radicand. And so what do you get?
You get 3 times the square root of x equals 39.
Good. Now what do?
And then you divide it by 3.
Okay, so we're going to get rid of the 3. So she's dividing it by 3. And you get?
You get 13.
Wait.
Sorry. You get this. You get the radicand is x, and then you get 13.
Now what do?
Then you square it.
Square both sides.
So you get x equals. I don't remember what 13 is.
Anyone want to help her? Very good. 169. All right. Any questions? All right. Y'all are doing page 472. Numbers 2 through 18 even. I'm going to be nice. We'll just do all that.
They're not gonna make us do third.
I'm going to do that one.
Oh, okay.
Yeah, I'll be nice. What time is it? Yeah.
The only reason why
Everyone can do it. It's due Friday. Okay?
tomorrow.
That's right. Tomorrow. It's due tomorrow.